Students, welcome to GK Pillai's maths classes. This is my first video on applications of trigonometry. In this chapter, you will find how trigonometry is used for finding heights and distances of various objects. Students will definitely get an idea about the type of questions they can expect in their exams with help from my videos. Watch my videos till the end. And don't forget to subscribe to my channel and help your friends also to be benefited from my videos. There are 6 important board examination questions in this video. Only the initial trigonometric ratios like sin theta equal to opposite side by hypotenuse, tan theta equal to opposite side by adjacent side, etc. and trigonometric ratios of certain angles are used in these type of sums. Understanding the question and drawing the correct diagram is very important. If you draw a wrong diagram, there is no use going further. It's a waste of time. Let me discuss this sum. A tree 12-meter high is broken at this point, and the top touches the ground and makes an angle with the top, an angle of 60 degrees. You have to find the height at which the tree is broken. Now let us keep this one to be x. This will be 12 minus x. So since these two sides are involved, we will use sine. Sine 60, you write the steps like this. Sine 60 degrees equal to AB upon AC. The value of sine 60 is root 3 by 2. X upon 12 minus x. Cross multiply and take x term to the left hand side. You will get 2x plus root 3x equal to this, and x common. You will get x into 2 plus root 3. Take this to the denominator and rationalize the denominator. You will get 12 root 3 into 2 minus root 3 upon 1. Now you can open the bracket by multiplying it. You will get 24 into 1.732 minus 36 equal to 5.57 meter. Therefore, the height at which the tree is broken is 5.57 meter. Now in these sums, there are two triangles involved. An aeroplane, when flying at a height of 5000 meters above the ground, passes vertically above another aeroplane. When the angles of elevation of the two aeroplanes from the same point on the ground are 60 degrees and 45 degrees respectively, you have to find the vertical distance between the two aeroplanes. A and B are the two aeroplanes, and from a point D, the angle of elevation of the first aeroplane is 60 degrees and the second one, the below one, is 45 degrees. Here, the entire height is 5000 meters, so this is also considered to be a easy sum. Let us write these things, and in right triangle ADC first, ADC, tan 60 will be equal to AC upon DC, root 3 equal to 5000 upon DC. Bring DC here and root 3 here. Let us take the other triangle DBC, tan 45 equal to BC upon DC. Here 1 equal to BC upon DC, so BC equal to DC, and DC is 5000 upon root 3, we will write here. Now the distance between the two aeroplanes AB equal to AC minus DC. DC is this, subtract from 5000 and rationalize this one, rationalize the denominator, we will get like this. Take the LCM, it will be 15,000 minus 5,000 into 1.73 upon 3, we will get 2113.3 meter. This is the distance between the two aeroplanes. Here, from the top of a hill, the angles of depression of two consecutive kilometer stones due east are found to be 30 degrees and 45 degrees. Find the height of the hill. For this question, you have to draw exactly like this only. Now, this is the top of the hill and these are the 2 kilometer stones. Most of the students were not knowing this one. The distance between the 2 kilometer stones is always 1 kilometer, 1000 meter. Now let us keep the height of the hill to be h and this portion x. and we will take this triangle first. In both the triangles, one complete side is not given. So this we have to do in a bit different way, the way we are doing here. So we will take the right triangle ABC, tan 45 equal to this upon this, h upon x. So equal to 1, so h equal to x. So we will take the right triangle ABD now. Tan 30 degrees equal to AB upon BD. 1 by root 3 equal to h upon this. Cross multiply, you will get h root 3 equal to x plus 1000. Here we know h is equal to x. Therefore, in the place of x, we will write h and take it to the left hand side. Take h common, you will get root 3 minus 1. Take it as the denominator, rationalize the denominator, you will get 1000 into root 3 plus 1 upon 2. So that is 500 into 2 will get cancelled with this one. 500 into 1.73 plus 1, 2.73. 500 into 2.73 will be 1365 meter. That is the height of the field. This is a bit different sum. A pole 5 meter high is fixed on the top of a tower. CD is the tower and this is the pole. The angle of elevation of the top of the pole as observed from a point A on the ground is 60 degrees. From here, the top of the pole is 60 degrees. And the angle of depression of the point A from the top of the tower is 45 degrees. You have to draw this parallel line, mark 45 here and then 45 here. These are the alternate interior angles. So this is the diagram. This also, we don't have complete side of a triangle is given. So let us do this way. Let us take this triangle. Tan 45 equal to CD upon AD. 1 equal to h upon x, h equal to x. Now we will take the bigger triangle. Tan 60 equal to h plus 5 upon x. If you write complete steps, proper steps, there will be no confusion by the people who are correcting your answer sheets. So we will write cross multiply and instead of x we will write h. Root 3h equal to this. Take h to the left hand side. Take h common. Root 3 minus 1. Take it as a denominator. So rationalize the denominator. You will get 5 into 1.73 plus 1. 3 minus 2. That will be 1 only. When you multiply 5 into this, you will get 13.66. That is the height of the tower. This is another important sum, but here one complete side of a triangle is given. A tower is 50 meter high. Its shadow is x meters shorter when the sun's altitude is 45 degrees than when it was 30 degrees. Find x to the nearest centimeter. Here there is a tower AB 50 meter high and there are two shadows. One is BC and the other one is BD. BC is when the angle of elevation is 45 degrees and 30 degrees BD. So when the angle of elevation is 45 degrees, the length of the shadow is x meters shorter and you have to find the value of x. So we will write in right triangle ABC, this type of steps you will write. In right triangle ABC, tan 45 equal to AB upon BC, 1 equal to 50 upon BC, we will get BC to be 50 meter. Now let us take the triangle ABD. Tan 30 equal to AB upon BD. 1 by root 3 equal to this, 50 upon 50 plus x, cross multiply, and you will get 50, you take it to the other side, take 50 common, you will get 50 into root 3 minus 1 equal to x. You can substitute the values and simplify, you will get 50 into 0.73, that is 36.5. So the value of x is 36.5. In this particular sum, this is an important sum. The angle of elevation of an aeroplane from a point on the ground is 45 degrees. From this point, the angle of elevation of an aeroplane located at this place is 45 degrees. After some time, after 15 seconds, the aeroplane is located at this point. Now the aeroplane has been flying at a constant height of 3000 meter. Here, you have to find the speed of the aeroplane. If you can find this distance, that divided by 15 will give you the speed of the aeroplane. So what we will do, we will write the step properly like this, and AB equal to CD equal to 3000 meter. Take this triangle with angle 45 degrees, tan 45 equal to AB upon PB. 1 equal to 3000 upon PB, and you will get PB to be 3000. PB is 3000. Now let us take the triangle PDC. Tan 30 degrees equal to CD upon PD, 3000 upon PD. So PD will become 3000 root 3. Now we want BD equal to PD minus PB. 3000 root 3 minus 3000. Take 3000 common, you will get like this. 3000 root 3 minus 1. Time is 50. Distance traveled by the aeroplane is this. Time is 15 seconds. Speed will be distance upon time. 15 will get cancelled with this one. 200 into root 3 minus 1. So this will be 200 into 0.73. We will get 146 meter per second. That is the speed of the aeroplane. In this particular video, I have also included some exam oriented science questions, and the MCQ questions of both science and maths will continue to be occupied at this place. My request is to subscribe to my channel and help others also to do so. Visit my description box and offer your comments so that you will be able to see more of my videos.